Okay, here we're going to talk about eccentric loading of columns. And what eccentric loading is when the column is loaded with a short distance from the center at a distance e shown here. So rather than being loaded right in the middle, it's got a displacement away. Okay, and what that does is it actually creates a slightly bigger moment than when you just have the buckling. Okay, so if I cut it to calculate what that moment you can see is not just the displacement or the deflection, but it's that plus the eccentricity away from the centroid that I have. Okay, I get this differential equation from setting that up with what we know about the relationship between the moment and the deflection. And the solution to that differential equation is given here. It's a little bit different than the last one because I have this E value that's also showing up here. So, but I can go through and I can set my conditions. I know that when x equals 0, v equals 0, okay, because we're looking at pinned at A and B, okay. So C2 is just left to be E if you solve that out, okay. I also know that when x equals L, v equals 0, which leads to C1 equaling the eccentricity times a tangent of this. Again, plugging in x equals L. You get something like that. So now, in order to find V max, which is often what we're interested in, again, is that max deflection. Okay, from symmetry, that max deflection is going to occur at L over 2. Okay, so just basically plugging L over 2 into the solution for this, I find that V max is given by this equation right here, where I have a secant in there. Okay, now using that, I can actually find the maximum stress because again, that moment is P times E plus V, and so for the maximum moment it's going to be E plus V max, which is basically, if I plug in V max that I have here, I get this for my moment. Now my maximum stress is both the normal stress as well as the bending stress. So plugging what I know about that moment into this equation, I actually get the maximum stress given this big ugly equation called the secant formula. Okay, and this is the equation that we use to find the stress and the eccentric loading of columns.